In this video, we are going to go over interior angle sum of polygons. So what does that mean? So when we're talking about the interior angle sum, we're talking about how much the angles add up to inside a polygon. So that could be a triangle, it could be any kind of quadrilateral or pentagon, or really any enclosed shape, such as the three that you see. So for our first one, we know that we have the number of sides, which is 3. And notice that they're listed on this table. If you want to copy down this table for your own reference later, it might be really useful. So for here, I have 3 sides. We know that a triangle has 180 degrees. And if I'm looking at a triangle, well, how many triangles are within a triangle? We're saying 1. So there's 1 triangle in there. So now I'm going to move on to the next shape. So my next shape is a quadrilateral. Notice it's not any particular kind. It's kind of odd shape. There's nothing that's really the same or parallel or anything like that. So it's just a quadrilateral. So if I want to be able to break this down into triangles, if I connect this point and this point, that gives me 2 triangles. So I end up with 2 triangles. Now I need to figure out how many degrees total are within this shape. So if I have 2 triangles, that's going to help us. If I know that this triangle here has 180 degrees, and I know that this one has 180 degrees, if I add those together, I know that this will have 360 degrees. So we're going to do this again. We're going to repeat this process, but with a 5-sided figure. So now we have a 5-sided figure. So I'm going to pick one common point, and I'm going to draw from each vertex and break it down. So I need to figure out how many triangles I have. And I can see that by doing it this way, I have 3. So I have 3 triangles. From there, I know that this has 180 degrees. This has 180 degrees. And this also has 180 degrees, which means that I have 3 times 180 degrees, which gives me 540 degrees. So let's start to notice a pattern here. If I have a 3-sided shape, I have 1 triangle. If I have a 4-sided shape, I have 2 triangles. If I have a 5-sided shape, I have 3 triangles. Notice that there's a consistent difference between these. Take a second, and if you can figure it out, write it down. If not, and you want to continue, that's fine. So notice that the difference between 3 and 1 is 2. The difference between 4 and 2 is 2. And the difference between 5 and 3 is 2. So that means we should be able to predict what happens if I had a 100-sided shape, which is crazy. So if that difference is 2, I should be able to say, well, 100 minus 2 would mean that I get 98 triangles. So I'm assuming that I have 98 triangles. And then to find out how many degrees, well, that means I have 98 triangles and they each are 180 degrees. So that should get me 17,640 degrees, which is insane. So 17,640 degrees inside a 100-sided figure. So hopefully we're starting to see a pattern. And now I'm going to say that it has n number of sides. So n just means the number of sides. It could literally be 5. It could be 10. It could be 20. It's whatever value we have of the number of sides. So I'm trying to generalize this now so I can apply it to different types of shapes. So notice that we said it was n, the number of sides, minus 2 to get us the number of triangles, right? So this ends up being n minus 2 here. Then to find my sum, notice that this is using this value, n minus 2, and multiplying it by 180. So we end up with n minus 2 times 180 degrees. So these are my 2 generalized equations. So anytime we're trying to find the interior angle sum of any sided shape, this right here is what we are going to be using. From there, we're going to be looking at interior angles of a regular polygon. So this is very important. Regular polygons mean that they have the same size of sides and all of their angles are exactly the same. So we're talking about everything is congruent about it. So notice in this example, we have this shape. We have 1, 2, 3, 4, 5, 6. So we have a hexagon. Notice that we have parallel sides. All the sides are congruent. All the angles are congruent. That's what makes it a regular polygon. We like to use regular polygons as much as possible because then we're actually able to determine individual angles. So I can determine the individual angle of just one of those, given that it is a regular hexagon. So how can I find it knowing the information I have right now? So let's go through this. We said that in order to find the sum of interior angles of a polygon, I can use this formula. So I'm just going to write this down here again. N minus 2 times 180 degrees. So our n in this case, because it's a hexagon, n is equal to 6. So we have 6 sides. So I'm going to plug that 6 in. So I end up with 6 minus 2 times 180, right? So we get 4 times 180, which gets me to 720. So this is 720 of the sum of interior angles. But now what if I want to find just one interior angle? Well, how many interior angles are there? There's 6. So the number of interior angles should always match up to whatever n is also. That means that I can say, well, if this is my sum and they all equal the same thing, I should be able to divide this number by the number of angles inside. So individual angles, only for a regular polygon, should end up being my sum divided by the number of angles I have. So that means that every angle is 120 degrees. And again, this is the number of angles in the polygon. And this is our sum of interior angles. So again, I highly recommend that you write these formulas down as you will be using them. If we want to generalize this one, I would almost write it as n minus 2 times 180, which is our sum, divided by n, which is the number of angles or sides that we have.